All right, B's and G's, welcome back to a delayed start, which it was a snow day, but fine being here version of the drive-through confessionals. Hungry for a sandwich? Stop by the deli. Make yourself a sandwich. What we're going to do today is go through 10-6, 10-7, and 10-8 notes. I'm kind of tailoring this to a fast version of this lesson, but remember, the nice thing about these videos is you can always pause it and rewind it. So if I get to something and I move too fast, just rewind it, okay? If I'm going too slow for you, then watch it and fast forward on YouTube. Okay, so 10-6 features some more angle arc theorems. The first one says, if two inscribed or tangent chord angles intercept the same arc, then those two angles must be congruent. So let's just think about this. Let's take a red angle. Let's take a red angle and intercept an arc. And let's take a blue angle and intercept the same arc. So notice that this red angle intercepts this pink arc, but the blue angle also intercepts the pink arc. So even though we don't know what the arc is, we called the arc x, we know that this angle would have to be x over 2. This angle would also have to be x over 2, and therefore these two angles are congruent. And then it could work the same way with tangent chord angles. So if I've got that, and then let's say I also have a green chord angle. Okay. Again, notice that this is the arc that the blue tangent chord angle intercepts, and it is also the arc that the green chord angle, so that makes these two angles congruent. So you got to look for that in pictures. Okay? More 10-6 notes. An inscribed angle in a semicircle is always a right angle. I told you this yesterday. This is one of my favorite little facts about circles and geometry. If I take any semicircle, okay, so make yourself a semicircle. Now I know it's a semicircle because I've just marked the center of the circle. If I create any angle that intercepts that semicircle, that right angle, or that black angle, has got to be a right angle. And I could do others. So I could do a red one and make it look totally different, but it's still a right angle. So look for those. Okay? And then finally, the final 10-6 theorem says that if you've got a tangent angle, which we refer to as the ice cream cone, the sum of this angle and its minor arc, which will always be the one that's closer to it. So angle x plus arc y will always be 180 degrees. So that can be a really useful fact when you're doing some problem solving. Okay, sometimes it might seem to you that you don't have enough information, and that might be the case where you need to remember that fact. Okay, moving on into 10-7, inscribed and circumscribed polygons. Okay, an inscribed polygon is a polygon that has all of its vertices that lie on the same circle. A circumscribed polygon is a polygon that has all of this should not say vertices. Sorry. This should say sides. Okay, so notice this one is inscribed, and it's also inside. And this one is circumscribed. pretty much just vocabulary words you need to know. Now here's some facts about them. This is pretty cool. You can open that door. Go ahead. You can let people in. So, if a quadrilateral is inscribed inside of a circle, so if this quadrilateral Q, U, A, D is inscribed, which this one is, then the opposite angles will always be supplementary. So angle Q plus angle A is equal to 180 degrees, and angle D plus angle U is equal to 180 degrees. And you can kind of think of that. If I just looked at Q and U, look at Q. Here's the angle. It's an inscribed angle. There's the arc that it intercepts. Here's A. Okay, there's that angle. And here's the arc that A intercepts. So if you think about it, the combination of the two angles will always form a complete circle. I don't know what's up with that. And that's why, remember that the inscribed angle is half the measure of the arc, and that is why they will always be supplementary. So think about this. If a parallelogram is inscribed in a circle, then what is a more specific name for that parallelogram? Well, what types of parallelograms have opposite angles that are supplementary? Well, that would mean they'd have to add to be 90. So if the opposite angles of a parallelogram, add to be 180, and they're congruent, then that must be a rectangle. You might want to draw a picture and try to inscribe any parallelogram. It won't work unless that parallelogram is a rectangle. So if you just try it a couple times, that might make more sense. Okay, moving on to 10.8. This is the last slide. So, like I said, it's not a ton of notes. The first power theorem, these deal with segments now. We learned a lot of theorems that dealt with angles in the last 2 days. Now these theorems deal with segments. So, the chord power theorem says, if this is A, and this is B, and that is C, and that's D. Let me get a better A. So if you have two chords that intersect inside of a circle, the products of their parts are equal. So A times B will always be equal to C times D. Okay? Now, here's another one. So, if we had a tangent secant, that's kind of tangent, just go with it, and a secant. Okay? So now we basically have to look at this as three segments. Here's segment A, here's segment B, and there's segment C. The equation for the tangent secant segments is that tangent squared is equal to the outside part times the entire thing. Okay? So outside squared equals part times whole is a way that you can think about that. Tangent squared is outer part times the whole thing. Okay? And then finally, we have a secant. The equation is going to be part times whole equals part times whole. So A times A plus B is equal to C times C plus D. Now, that's a quick video. We got less than 10 minutes. It's 3 sections, so obviously we're just touching on all of the notes from this section. So it might be a good idea to watch this video, start doing your homework, and then maybe watch the video again. And there certainly are some things in here that you need to put in your notes. If you look in your book, they use some different notation, but these theorems are the same. So use whichever notation makes more sense to you. Stay warm. Go sled riding. Boom! Boom, ye! Boom! Boom!